Hello everyone. So in this video lecture, we are continuing with the previous lecture, that is lecture number 5, and we will finish remaining part of that lecture. So we were discussing on data conversion programs in a C programming language for 8051 microcontroller, and we discussed about data conversion programs, how to convert packed BCD to ASCII, how to convert ASCII to packed BCD, and how to convert binary to decimal. Uh, the remaining part that we could not complete, that is a checksum byte calculation and its significance, that we will do today. Okay, so we will directly go to that slide. Okay, so this is the point, that is checksum byte in ROM and its calculation. Okay, so normally what we do in embedded system, once hardware is ready, okay, parallelly we write software for that, and once that software is written, that is program is written, what we normally do, we use some compiler, for example kill compiler for 8051 microcontroller, to write the program to build its hex file, and we can check that program there, and once we feel that program is ready, then we will write its hex file consisting of series of bytes, that is program, in program ROM of microcontroller. Okay, so that is the process. So for that we use some third-party softwares to write or burn that hex file into program ROM of microcontroller. Okay, so in these programs we should check the integrity of ROM contents, that is program ROM contents, after that hex file is written. That means after writing that hex file into program ROM of 8051, we have to correct, we have to check its correctness, okay, whether that hex file is written correctly or not. So that is called as ensuring integrity of ROM contents. Okay, so every time when we write that hex file into program ROM of any microcontroller, we must perform this integrity check, and we do this integrity check of ROM contents by using checksum calculation. Okay, so checksum calculation, actually if we perform, so the process of this checksum calculation detects any corruption of the contents in ROM, program ROM of microcontroller. Okay, so this checksum process uses what is called a checksum byte, that is a single byte, that is called as checksum byte. Okay, so this checksum byte we calculate from the hex file content. Okay, so what hex file content? It contains number of bytes depending on size of your original program. Okay, so by using these bytes in hex file that is to be written into program ROM, we will calculate this checksum byte. Okay, and this checksum byte is appended or tagged in the end of that series of bytes of data to be written into program ROM, that is nothing but hex file. Okay, so in the end of that hex file contains hex codes, series of hex codes. So in the end of that hex codes, we will write this extra byte, that is called as checksum byte. Okay, so that will get written with original hex files uh, on the program ROM of microcontroller. Okay, and by using that checksum byte, we can perform integrity check. Now, how to calculate that checksum byte? Okay, that is calculation of checksum byte of series of data. That involves two steps actually. First, what we have to do, we have to add the bytes together and drop the carries. Means whatever contents of bytes in hex file of your program. Okay, so all these hex codes, that is bytes, are added together, and while adding we have to ignore carries that will get generated after each addition. Okay, after that finally we will get a single byte. Okay, because we have ignored all the carries generated, so result will be a byte. Okay, and we will take 2's complement of that byte, that is actually sum. Okay, and this is called after taking 2's complement, whatever byte we will get, this is called as checksum byte. Okay, and which becomes the last byte of the series. So that checksum byte is appended in the last to the contents of hex file, that is series of bytes, and that will get written with checksum byte in the end. Okay, on the program ROM. In this way we can calculate checksum byte. Okay, now we will write a program that will calculate checksum byte just for your illustration. Okay, so statement is write an 8051C program to calculate the checksum byte for the data 25, 62, 3F and 52. Okay, so just for experimentation we have here only four bytes. Okay, we can assume that our program is of 4 bytes, that is its hex file contains only 4 hex codes or 4 bytes. Okay, and these bytes should be written into program ROM. Okay, and with these 4 bytes we have to perform checksum byte calculation. Okay, and after that we will get that checksum byte, and that checksum byte will get written in the last with these 4 bytes on program ROM of microcontroller. Okay, and that will help us to check its integrity, whether these 4 bytes are written properly or not, whether these 4 bytes are correct or corrupted. Okay, because if we don't write the hex file properly into program ROM, okay, so that program will not work properly. Okay, so we have to check the integrity of program we have written into program ROM. Okay, so for that this facility of checksum byte is there. So with these 4 bytes we will write a fifth byte, that is called a checksum byte. Now how to calculate that checksum byte? So for that program is written here. Okay, so as usual we are including reg51.h, and this is a main function, the only function in your program. So first statement is declaration statement, unsigned char my data square opening and closing brackets. Okay, so by using this declaration statement I am declaring my data as an array, okay, of unsigned char data type. Okay, that means in my data array the element of data could be of type unsigned char. Okay, means each element in this my data array could be data of type unsigned char. Okay, that means in the range of 0 to 255. Okay, and in this array we are storing these four bytes. Okay, that is 25h, that is 0x25, 0x62, 0x3f, 0x52, separated by commas and enclosed in braces, opening brace and closing brace, and this statement is ending with semicolon. So this first statement declaring my data as an array of unsigned char, and in that array we are storing 4 elements, that is nothing but these 4 bytes. Okay, so without that we cannot process these 4 bytes. Okay, then I'm declaring one more variable having name sum, and it is of type unsigned char. Okay, and it is being initialized with value 0. Okay, and semicolon. So this second is also declaration statement which is declaring sum as unsigned char type of variable, and itala initial value what we are assigning 0. Okay, then again one more variable I am declaring, that is x having name x of unsigned char type. Okay, one more variable that is having name chksum bit, checksum byte. Okay, that is checksum, to hold the calculated checksum byte I am declaring one more variable having name chksum byte. Okay, of type unsigned char. Okay, next for loop is there. Okay, and for loop first expression is x is equal to 0, second is x is less than 4, and third is x plus plus. Okay, means this loop will be repeated until value in x is less than 4, and we are starting with value in x 0, means this loop will be repeated 4 times, because we are going to add these 4 numbers to calculate checksum byte. Okay, so for that this loop is written. Okay, uh, so first see in this loop, p2 is equal to my data in square bracket x semi-comma. So this first statement simply it is displaying the element from my data array. Okay, so initially value of x is 0, means first time when this loop statements executed on port 2, first element in my data, that is 25, hex number 25 will get displayed on port 2. Okay, this is just to view which element we are adding. Okay, then sum is equal to sum plus my data in square bracket x semi comma. This means we are adding in sum what, my data in square bracket x, and x मध्ये काय आहे 0, means we are adding first element into sum. Initially sum मध्ये काय आहे 0 आहे, so 0 will get added with 0x25, so that sum will be 0x25, and that will be stored again in variable sum. Okay, next p1 is equal to sum. On port 1 I am displaying that sum, means when this third statement executed, what will get displayed on port 1, 0x25, that 25h will get displayed on port 1. Next time x will get incremented by 1, again this condition will be checked. Now in value in x will get incremented, means it will become 1, again this condition will true, again this loop will be repeated. Now p2 is equal to my data in square bracket x semi comma, x is having now value 1. Okay, so my data in square bracket 1 means second element in my data, that is this 0x62, that will get displayed on port. Okay, then sum is equal to sum plus my data in square bracket 1 semi comma. Now what is in sum? In sum there is a 0x25. Okay, in that I am adding my data in square bracket x, means now x is having value 1, means my data in square bracket 1 means it is pointing towards second element in this my data array. Okay, that is 0x62, means 0x62 will get added in content, whatever content in there in sum. Right now content in same is 25, so 25 and 62 will get added together, and that will get stored in sum. Okay, so whatever that sum, that will we are outputting to port 1. Okay, so in this way all these 4 numbers will get added due to this for loop, and when value in x becomes 4, this loop will get terminated and control will go down to the next statement, that is this statement. Okay, so here chk sum byte is equal to tilt sum plus 1, means actually what we are doing here. So to calculate checksum byte after addition of all the series of data, what we have to do, we have to take its 2's complement. Okay, so these are the 2 steps to calculate checksum byte. First we have to add all the bytes, and then we have to take its 2's complement. Okay, so this statement checksum byte is equal to tilt sum plus 1, what it is doing, see. So tilt is operating on content of sum मध्ये काय आहे आता, addition of all these 4 bytes. Okay, so we are taking its 1's complement. Okay, inversion operation, bitwise inversion operation on this sum will happen. That means we are taking 1's complement of whatever contents are there in sum, and into that we are adding 1, means we are making it as 2's complement. Okay, so simply we are taking 2's complement of whatever content in variable sum. Okay, and that will get stored on in variable checksum byte. Okay, and p1 is equal to checksum byte, and that checksum byte calculated we are displaying on port 1. Okay, in this way we can calculate checksum byte. Okay, so what we did, we first added all these series of bytes. Okay, and then we have taken its 2's complement, and then we are displaying that checksum byte calculated. Okay, on port 1. Now next, checking data integrity using checksum byte. So as I told you, this calculated checksum byte with all these 4 bytes. Okay, in the end of these 4 bytes, that checksum byte will get written. Okay, and all these 5 bytes will get written into program ROM. Okay, and after that these 5 bytes will get written, okay, data integrity will get checked, okay, whether that these 4 bytes are properly get written, okay, or not. That can be checked by using the last byte, that is checksum byte, that is also get written with these 4 bytes on program ROM. So how to do that, that is given here, that is checking data integrity using checksum byte, that is get written with data bytes or program bytes. The series of bytes with the checksum byte is written in program ROM, okay. Um, after the data is written in program ROM, its integrity or correctness can be checked using the following steps, okay. So after writing all the bytes, and in these after these bytes we will have checksum byte, okay. What we have to do to check the correctness or integrity of that data? First, we have to add all the bytes written in program, including the checksum byte. Okay, so these 4 bytes as well as the last checksum byte. Okay, so these 5 bytes will write in program ROM. So after that, to check its integrity or correctness, what we do, we add all these bytes including checksum byte, and we also drop all the carries generated in subsequent additions. Okay, now if the final sum is 0, if it is equal to 0, means after addition of all the bytes including checksum byte, if result is 0, that means data is good, means that series of bytes, program bytes that are written in a program ROM, that is correct, okay, if the sum comes 0. And if it is non-zero, if some result is non-zero, that means data is corrupted, that means data is not written properly, there is some corruption, so you have to rewrite that data again, okay. In this way we can check uh, data integrity by using checksum byte, okay. So for that, program is written. So write an 8051C program to perform checksum operation to ensure data integrity. If data is good, send ASCII character G to port 0, otherwise send B, okay, to port 0. G means data is good, B means data is bad, okay. Now see here, for that program is written. So from previous example, all these same 4 bytes are taken in addition with checksum byte, okay, whatever we get after running this program, and that is actually we will get E8, okay. So see here, program include reg51.h, and this is main function in your program. So first, like previous program, I am declaring my data as unsigned char type of array, in which first four bytes are actually program bytes, okay, that is data bytes to be written into program ROM, okay. And last byte, fifth byte, is that is 0xE8 is checksum byte, okay. So we are assuming that these 5 bytes are written in program ROM, and we have these 5 bytes. Now we have to decide on whether this data is written correctly or there is some corruption, okay. How we will check? We will simply add all these 5 bytes, okay, while ignoring carries that will get generated, means I will add 25, 62, okay, then I will add 3f into it, then 52 into it, and finally this checksum byte I will add. And after this, if I get result 0, means data is correct, and I have to display G on port 0, means data is good, okay. And if the sum comes non-zero, okay, okay, there was some interruption, okay. So in this way we can check data integrity or correctness of data. Now see the remaining program. So unsigned char shk sum is equal to 0. I am declaring sh, uh, here should be chk sum, okay, is equal to 0. I'm declaring chk sum as unsigned char type of variable, and I'm initializing it with value 0. Then I'm declaring one more variable x of same type, that is unsigned char, okay. Then for loop is there, for x is equal to 0 semi comma, x is less than 5 and x plus plus. Okay, so first value x will get initialized with value 0. Okay, and condition for continuation of loop is x is less than 5, means this loop will be repeated from uh, value in x is equal to 0 to 4, means 5 times this loop will get executed. Okay, there is only one statement in this loop, so it is not enclosed in between opening and closing braces. Okay, so see the statement in the loop. So this is the statement in the loop: chk sum is equal to chk sum plus my data in square bracket x semicolon. Okay, so what we are doing, we are adding each element from this my data in chk sum variable. So here not s, it is c, chk sum, which is initialized with value 0. Initially in chk sum value, what value is there? 0, and into this I am adding each element in this array. Okay, 5 elements. Okay, so first 25 will get added because x initial value is 0, so my data in square bracket 0 is actually pointing to first element in this my data array, so that will get added into 0, and that sum finally get assigned to this chk sum. Okay, next time x will get incremented by 1, value in x will become 1, still this condition is true, so again this loop statement will be executed. So checksum is equal to checksum plus my data x. Now x is having value 1, means it is pointing to next element in the array, that will get added into checksum byte. In checksum byte there is a number, first number, that is 25, both will get added and that value will get assigned to chk sum variable. Okay, in this way all these 5 bytes will get added and finally the result is in chk sum. Okay, then we are determining whether this data is correctly written or not. Okay, so if statement is there, if else, if in parenthesis chk sum is equal to 0. Okay, so double equal to means it is a relational operator, so this statement is a relational it is a relational expression, and it will either return true or false value. Okay, so if chk sum is equal to 0, if this is true, means chk sum मध्ये जर का 0 value असेल, then we are going to execute this statement: p0 is equal to in a single quote g semi comma. Okay, if checksum मध्ये जर का value 0 असेल तर याचा अर्थ काय? So that data is correct. Okay, it is not corrupted. Okay, according to the whatever steps involving checking data integrity is we discussed. Okay, if the final sum is 0 means data is good, if it is non-zero means data is corrupted. Okay, so here we are checking value in chk sum variable. If it is 0 means data is good and we are going to display g later on port 0. In single quote g means the ASCII code of g will get outputted to port 0, and port 0 will display later g. Okay, means data is good. Else means checksum in checksum variable, if value is non-zero means data is not good, means it is corrupted, means it is not properly written in a program ROM. Okay, so we will display b, means data is bad, on port 0. In this way we can check the data integrity of data that is written in a program ROM with checksum byte in the end. Okay, simply we have to add all these bytes with checksum byte, and if it that addition comes 0 means data is good, and if not, that means data is bad. So if the data is corrupted or bad, then again we have to repeat the process of writing these bytes into program ROM. Okay, so in this way we can use checksum byte to check data integrity of data written in ROM or program ROM of microcontroller. So this is very important. I think you have understood, and this part was remaining, so I conducted this lecture. Okay, so I think the things are clear about checksum byte and its calculation and checking data integrity using checksum byte. Okay, so if any questions we will discuss in live session. Okay, so I think I can stop here. Thank you very much.